We will host on our own metal, on our own machines. We are now on the internet. Our website is live. You can see it's working. Are you ready? Welcome back to episode 9 of building the OpenSource-Odyssey website. And in this very exciting episode, we will go live.
We'll do it live!
We will ship the project, meaning that by the end of this video, our promising looking project will be accessible by anybody, by yourself. You can then go on OpenSource-Odyssey.net and check out the website that we've built so far. This is going to be a very exciting and interesting video for anybody that's interested in hosting applications by themselves.
Just do it!
We have a very innovative approach, I believe, to hosting, because we will not be using the cloud. We will host on our own metal, on our own machines. To me, it's very exciting. Let's dive right in. And first, I want to present the tools that we will be using in this video. As a web server, I will be using Caddy. Caddy is a very nice tool as an alternative to something like Apache or Nginx. Basically, service that sits on your server and knows how to handle the different requests that are coming in. So you can map a domain or a subdomain to some process port or to some file directory. And it's very minimal in the syntax that you need to use and handle certificate automatically and all that good stuff. So very beginner friendly tool, and I love Caddy for all my reverse proxies. And we will be using reverse proxies. The other point here I have is we'll be using wireguard. I already have this set up, but I will briefly show how it works. And this means that we can have a VPN tunnel between our server that is exposed to the internet and our server that is actually hosting the application. And finally, we will also be using PM2 as a process manager to start our application, to make it reboot safe and just a long running process that is always running in the background on our server. So just for completeness sakes, this is the website of PM2. It's an advanced production process manager for Node.js. We are writing a Node.js application, so this is perfect for us. And the other tool we'll be using is wireguard, where we have a fast, modern, secure VPN tunnel between two machines. WireGuard is really the modern way of doing VPNs. It's very easy to configure. You don't have to handle certificates as in OpenVPN. It's pretty easy to set up, although I have to admit I did my fair bit of bashing my head against the wall for a time, but now I think I've kind of gotten around how it works, and once you know how to do it once, it's easy to replicate, and you can connect all kinds of machines to each other that are talking directly with a secure tunnel to each other, and it's very, very fast. Also, just for completeness sakes, I touched on this in the last video, but I want to go into how the current website works. So by the time you're watching this video, probably it will be changed already. But if you right now go to OpenSource-Odyssey.net, you will find this website, which is a static GoHugo.io website. It's generated through a single org document and then spit out into a theme that makes everything look nice. So we will be replacing this and maybe put it on a subdomain, something like blog-opensource-odyssey.net. We will still have access to it, but it will not be the primary site anymore. This website is currently also served with Caddy. So maybe let's check this out right now. Here I am on the remote server that is hosting this OpenSource-Odyssey website, and this is my Caddy configuration right now. And all we're really saying here is that we want to map all of the requests that are incoming on OpenSource-Odyssey.net to a file server where this is the location of the static files. And in this video, we will replace this, of course, this block, and make it respond to a port with our WireGuard tunnel. Let's dive a little bit into the architecture of how this will work. I mentioned that I actually use two servers. One server that is a VPS that I've rented. So this is not my own machine. This machine is exposed to the internet and my domain registrar is pointing to the IP address of this server. This is very nice because I can go for a cheap VPS. I don't really have to care about storage at all because nothing will be stored on this machine. All that will be stored here is the web server with its configuration, and then the requests that are incoming to this server from the internet are going to be forwarded through a WireGuard tunnel to my local server. So this is a server that I have the control over, that is my machine, and this machine will actually be running the payload application and our MongoDB database. Everything that's coming in here will be forwarded to here, then respond and go back to the user. And again, this has the advantage, first of all, that we can go for a cheap VPS. Another advantage is that we can have a server kind of connected to the internet indirectly without actually having to set up port forwarding on our own router and potentially risk some security vulnerability. So it's a much safer approach to hosting applications from the security of your basement without actually having to expose your local network to the internet. And this architecture, I love it, yes?
Yes.
Because you can do so many things. You can host not only a payload application, but you could host a Nextcloud instance or I don't know what, yeah? Any application that you can think about in the self-hosting ecosphere, there are many applications that you can self-host, could benefit from something like this. Yeah, then you could also retire an older laptop that will always be running and your local server where you can run applications and just have it connected to the internet through a WireGuard tunnel. So let's take a look in how this actually works. Right now I have the remote server connected to the local server and I can ping between them. So if I enter the IP address of the local server, which is 10.10.9.2, then I'm getting back the successful pings. So right now this remote server is pinging this local server. They're not on the same location. And vice versa, if I'm on my local server and I want to ping the remote server, then I would go for the IP 10.10.9.1. And similarly, this local server is now pinging the remote server. So you should have your WireGuard set up already this way, so these two machines can ping each other. In other words, they are connected. I won't go into how I'm setting up the WireGuard connection in this video. If that is something of interest to you, please leave a comment in the video section or maybe just go to the official website and try to read through it first. And I'm sure there are many other great videos that show you how to set up a WireGuard connection. All right. I'm here in my home directory of my local server and I have nothing really in here. So first what we need to do is we need to clone the repository from our GitLab instance. So from here onto this local server. And we do this by cloning with SSH, writing git clone.
Shame.
All right, that did not quite work yet because I needed to set up a SSH key. So what I did was I added an SSH config where I said that the GitLab should use this key pair. And then I needed to create the actual key pair that I will be using to access this repository. So now let's try this again with the git clone command. And I'm using SSH again. And again, we are rejected. So I think what we need to do is we need to set a deploy key. Since what we are doing right now is actually to deploy, we need to add this key. I need to cat my public key. And with this, I can add it here. Let's say open source, add the key, make sure that the formatting is correct. All right, this is looking good. Do we want to grant write permissions to this key? No. And so let's add the key and try it again then. So I'm going to clone again. And now it's working.
That was legitness.
This makes me wonder though. Does it mean that the repository is private and nobody can clone it? Or is it possible to clone with the HTTPS? Leave a comment in the comment section if you had any issues with cloning this repository. So now we have the website right here. Let's go into the website and everything should already be present. So what I need to do is install all of the dependencies, and just a side note, I aliased pnpm to pn just to save 2 keystrokes and be so much more efficient and productive. All right, so the dependencies installed correctly. Now let's try to build the application, and hey, check this out.
Wicked sick.
So I'm getting an error because what I forgot was to put my env file on the server. So right away, we can see the benefits of what we did in one of the first videos, is setting up the quality of life with the validation of our env file. And so this is paying off right now. Great. So I need to create a env file, and I'm doing this with Vim, of course. Add this here, and right now, I'm sorry, we have to blur the screen or put a black box over it because now we are on production, and of course I can't share these secrets easily with you. After updating our end file or the secrets for our end file, we also need to update the next public server URL, because this is going to be the URL where we will replace stuff dynamically in our app. So this needs to point, of course, to our actual domain. So here we're going to put the OpenSource-Odyssey.net, and without a port, because the port is going to be handled by caddy. Now we can write and quit this application, Vim right here. In case you didn't know, you can quit Vim with :Q and maybe give it a bang if you don't want to write the file. If you do want to write the file, you can do it like this with a write, quit, and exclamation mark. But in either case, let's quickly now build our application, because this should now work.
Never give up, no, no, no. I won't give up, no, no, no. Let me up you.
Great. Next.js finished building our website, and it gives us this little summary that we can scroll through, and it will indicate which routes were built and how they were built. For example, the post right now is a complete static site. Then we have some server-side generated pages, and we have some fully dynamic pages, like the Slug page, for example. So now what we can do is we can start our application with the pnpm start command that is in our package.json. And this will bring up the application under localhost 3000 as we are used to. The next step we have to take is kind of encoding our start command into PM2. And we can do this by creating an ecosystem.config.commonJS, so CJS file, where we can name our process, how it will be called in PM2. We can pass it our script, so basically the command we want to run, and an argument that it should execute. And this will map to our package.json, to our start command here, right here. Let's make this, resize it a little bit. Actually, let's move it down so we can see both. Very nice. All right. What I want to do here is I want to change the port of my application. The default port is 3000, and if all of my payload applications ran on port 3000, they would conflict with one another.
There must be another way!
So I need to pass the P flag here, and let's go with 3325 as a port for our application. So now when I execute pm2 start, the name of this configuration file, it will execute this command where we say next start under the port 3325. So what I need to do now is give this a commit, and let's say add pm2 configuration for prod, give this a push, enter the password for our SSH key, and now this will be updated. So on the local server, I can do a git pull. Now I will receive the changed package.json and the newly added ecosystem. And now I should be able to say pm2 start ecosystem. And that should bring up my pm2 process right here. And it it is starting the OpenSource-Odyssey process. So we can inspect this by going with pm2 logs. And here we get the output of our application where we are informed that this is running under localhost 3325. Exactly what we want. This is already the left part of our puzzle here. So we have the local server with our payload application running. MongoDB was also running beforehand. And now we just need to configure the web server to send the traffic that is coming in to OpenSource-Odyssey to this payload application instead of a file directory on the server itself. So let's switch over to our remote server, and I'm going to edit the caddy file here. And what I want to do first is let's just copy all of this down, because I do want to keep my application right here. I just don't want it to be the main site. So I will remove this block right here. And here I will add a blog in front of the OpenSource-Odyssey. So now this is, if you go to the subdomain of blog OpenSource-Odyssey, you will still be able to access the legacy site. And I make these changes by restarting the caddy process. So this would be systemctl. I am already root, so I don't need sudo. Restart caddy. And now if I go to this website and I refresh, I still get it.
Wow.
All right, so I guess this was a caching thing from my browser. But if I now go to blog OpenSource-Odyssey.net, I go to the blog. I guess because I left in also the other block, that's why it was working. So now what we need to do here is we need to set especially this section right here to be a reverse proxy. Unfortunately, this is pretty easy. We can just say reverse proxy, but just to be safe, let's also look up the documentation on caddy. So the reverse proxy right here, scroll down to where it is in a caddy file. This is not the right spot. Let's say caddy file reverse. Yeah, exactly. So this is what we want. Reverse underscore proxy and then the IP address where it should be forwarded to. Like I showed in the beginning, we already have wireguard set up. And the IP address for my local machine, for my local server right here is 10.10.9.2. And now we need to specify the port. So this would be 3325. And if I give this now a save, I restart my caddy server and I remove the block from the start here. As you can see, we are still on that side. I give it a hard refresh.
Well, look, we made it.
And voila, we made it. We are now on the internet. Our website is live. You can see nothing. There's no content here, but it's working. And what we need to do now is we need to go to /admin and create our admin user for the first time. And then we are able to log into the admin panel and administer our page. So this time I want to make sure that I have a secure password and I use an email address that actually belongs to me. We are still not sending out emails, but the password should be secure. I can click create now. Let's save this to the browser so we can easily come back to it. And first order of business is of course to switch to the dark theme.
I just want to die!
That is basically it. Now the website is on the internet. We can go to it with OpenSource-Odyssey.net. I hope you check it out. And if you want to check out the blog, this is also still available under blog.opensourceodyssey.net. So thank you so much for watching this video. This was a very important milestone. We are live. I am so proud to say it that after, 9 videos already, we are rolling on the internet. Let's be honest, it's very minimal and very basic, but at least we are on the internet. So the most important step is done. In the next episode, we will fill this page with live. We will link up all of the videos that already exist and maybe make some more to-do items of what is not quite ideal that we need to fix in the future. Again, thank you so much for watching. Leave a like and a comment, leaving some feedback, subscribe to the channel, and I'll see you in the next one. Onwards, cypherpunks.